Okay, so to integrate this problem, this is problem 14 in exam 1 review. You need two things. The derivative of tangent u is secant squared u du, and the log rule. The integral of du over u is ln of u plus c. This is from section 5.1. Here we go. So let u be equal to 4 plus tangent 6x. We now get the du with respect to x. The derivative of 4 is 0. The derivative of tangent is secant squared 6x. But we have to use chain rule here. We need to get the derivative of 6x, which of course is 6. So your du is secant squared 6x, 6 dx. You notice that your problem doesn't have the 6 there. So we're going to solve this for du and then do the necessary adjustment, okay? So I can write this as du over 6 is equal to secant squared 6x dx. So that's now exactly what we have on top. The denominator simply becomes u, and so we can use the log rule here. Here we go. So secant squared 6x dx will be now written as du over 6. And the denominator 4 plus tangent 6x is simply u. You notice that I didn't put my limits here. It's because the problem is using the variable x, and the limits are 0 to pi over 24. When we change the variable to u, this must also change. So let's go ahead and do that. So if x is 0, I'm using the 0 here in the denominator, in the lower limit, then u becomes 4 plus tangent 6 times 0. 6 times 0 is 0. Tangent 0 is 0. So the limit becomes 4. If x is pi over 24, then u becomes, this is the upper limit now, 4 plus tangent 6 times pi over 24, which will become 4 plus tangent, well, 6 times pi over 24 is pi over 4. Tangent of pi over 4 is 1, and so the limit simply becomes 5. So there you go. We can now rewrite this as, look at this, the integral from 4 to 5 of du over u. Where will I put the 6? Well, I can pull that out as 1/6 outside. It's a constant, so we can always pull it out. And so we're done. The integral of this is ln of u. And we will simply evaluate this from 4 to 5. And so we get 1/6 ln of 5 minus ln of 4. That's your final answer. Done. Properties of logarithms. From college algebra, we learned that if you have logarithm of b over c, we can rewrite that as log of b minus log of c. And that is precisely what we have here. So I can write it as 1/6 ln of 5 over 4. That's another acceptable answer. Still another, we can use this property of logarithms. Logarithm of b to the c can be written as c times log of b. So we can write that 1/6 as a power, ln of 5/4 to the 1/6. And then using the algebra rule that says a to the power n over d is equal to the disc root of a to the n. This can now be written also as ln of the 6th root of 5/4. That's another acceptable answer. This is problem 21 of your exam 1 review. The definite integral from 0 to pi over 16 of, in parentheses, 1 plus e to the power tangent 4x secant squared 4x dx. To be able to solve this problem, you need two things. You need to get the integral of e to the u du, which is e to the u. This is section 5.3. And then you must know the derivative of tangent, which of course is secant squared, and trigonometric values of special angles. Okay, here we go. So again, we will use u substitution here. So let u be equal to tangent 4x. So we get the derivative of u with respect to x, and that's going to be secant squared 4x times the derivative of 4x. So we get here secant squared 4x 4 dx. That's our du. And if you look at your integral here, there is no 4 in the du part. So we will solve this for du. And we get du over 4 is equal to secant squared 4x dx. So that is exactly what we have there. Okay, so I'm going to rewrite out the problem in terms of u. We have 1 plus e to the u. Now instead of simply writing du, I will put du over 4, because that's the equivalent of secant squared 4x dx, which we can move outside. So we get 1/4 times the integral of 1 plus e to the u du. Okay, if you notice, I did not put my limits here because those are the limits in terms of x. So to be able to find the limits here, we will use this thing. So let x be equal to 0, the lower limit. And so u, this is now our u, is equal to tangent 4x, which is now 4 times 0, which is 0. And tangent 0 is 0. That's from your unit circle. So the lower limit of 0 still becomes 0 here. Now if we let x be equal to pi over 16, the upper limit there, our u will take on the following value. Tangent of 4 times pi over 16. Well, 4 times pi over 16 is pi over 4. Tangent pi over 4 is 1 from your unit circle. And so our integral now becomes 1/4 times the definite integral from 0 to 1 of 1 plus e to the u du. So here we go. Let's integrate that. The integral of 1 is u. The integral of e to the u du is e to the u. Evaluating from 0 to 1, we get 1/4, 1 plus e to the 1 minus 0 plus e to the 0th. Simplifying our answer, we get 1 plus e. Well, e to the 0th is 1, so I will get minus 1, which reduces our answer to e to the 4 over 4.